Keeping up with AI, it's like drinking from a fire hose, you know?
Oh, yeah, definitely. Articles research new models every day.
It's overwhelming to say the least. But hey, that's why we do this. Welcome to the deep dive.
Your shortcut to understanding what actually matters in AI.
So today we're going to dive into something that could fundamentally change how we build AI applications.
Yeah, it's called the Model Context Protocol, or MCP.
MCP, and I know it might sound a little intimidating, but uh, think back to the days before USB.
Oh my God,
You had a different cable for your printer, your scanner, your mouse. It was a
a
mess.
total nightmare.
Then USB came along and standardized everything. That's the idea behind MCP, but for AI.
Yeah, it's like the USB-C for AI applications. It's all about creating a standard way for AI models to talk to different data sources and tools.
And for you, our listener, the goal of this deep dive is to understand what MCP is, why it matters, and how it could help us build more powerful AI. We're going to look at the architecture, the key components, even a practical application to give you a solid foundation.
Exactly. And don't worry, we're not going to get bogged down in the technical weeds. We want to make this accessible for everyone.
And to do that, we've got some great resources lined up. We'll be looking at excerpts from the official MCP documentation and a really helpful YouTube tutorial that shows you how to actually build an MCP server.
It's a great way to see MCP in action.
So let's start with the basics. Why MCP? What problem is it trying to solve?
So the core issue is that even the most advanced large language models, these LLMs we always hear about,
Right.
they often need to connect to external information and tools to be really useful. For building things like AI agents or those complex workflows.
So they can't just work in isolation.
Exactly. They need to be able to access data, interact with systems. It's like, think of it like a brain without a body.
Mm.
It can think, but it can't act on those thoughts. So MCP provides the standardized way for AI models to interact with the world around them.
So it's like USB unlocked all that potential for hardware by making it easy to connect different devices.
Hmm.
MCP is doing the same thing for AI applications.
Exactly. And that has some huge benefits for developers and users alike.
Okay, so let's break down those benefits. What's in it for the developers who are building these AI applications?
Well, for one thing, there's a rapidly growing library of pre-built integrations for MCP. So developers don't have to reinvent the wheel every time they want to connect their AI to a new data source or tool.
So it's like a plug-and-play system for AI.
Exactly. And another big advantage is flexibility. With MCP, you're not locked into a specific LLM provider.
Oh, interesting.
Yeah, if you decide that a different model might be better suited for a particular task, you can potentially swap it out without having to rewrite all your connections.
That makes sense. So you're not starting from scratch every time.
Exactly. And on top of all that, MCP encourages best practices for data security. Because the connections are standardized, you have more control over how and where your data is accessed.
And that's a big deal these days, especially with all the concerns about data privacy and security. Okay, so this all sounds great for developers.
Mhm.
But what about the people actually using these AI applications? How does MCP benefit them?
So for users, MCP means more powerful and more versatile AI tools because developers can build more sophisticated workflows that tap into a wider range of data and functionality.
So these AI tools can actually do more and do it better because of MCP.
Exactly. And because MCP encourages better data security practices, users can have more confidence that their data is being handled responsibly.
That's definitely reassuring.
Right.
Okay, so we've talked about the why behind MCP. Let's get into the how. What's the general architecture of this thing? How does it all work?
So MCP uses what's called a client-server architecture.
Okay.
Think of it this way. You have MCP hosts, which are your AI applications themselves. This could be something like Claude Desktop or even an AI-powered feature in your coding environment.
Got it.
Then within these hosts, you have MCP clients, and each client maintains a one-to-one connection with an MCP server.
So the clients are like the messengers between the AI applications and the servers.
Exactly. And these MCP servers are lightweight programs that expose specific capabilities, like accessing a database, searching the internet, or interacting with some online service.
Okay.
And these servers can connect to local data sources like files on your computer or a company database.
Right.
Or they can connect to remote services over the internet like an API.
So it's a network of interconnected pieces all communicating using this common language, MCP.
That's it. And now let's delve into those core architectural components that the documentation talks about. What are the fundamental building blocks here?
Okay, let's break it down.
The first layer is the protocol layer. This handles the structure of communication, things like how messages are formatted, how requests and responses are linked, and the overall patterns of interaction.
So it's the rule book for how everyone talks to each other.
Right. And the documentation mentions some key classes here. Protocol, client, and server. These are the software components that manage that communication.
Got it. What's the next layer?
The next layer is the transport layer. This is the actual method used for sending and receiving messages.
Okay.
MCP supports a couple of main types. There's STEO, which uses standard input and output. It's simple and efficient for things happening locally on your computer.
Right, like two programs talking to each other on the same machine.
Exactly. And for connections that need to go further, there's HTTP with SSE. This uses standard web technologies, server-sent events for pushing messages from the server to the client, and regular HTTP PST requests for the client to send messages to the server.
Got it.
But no matter which method is used, all communication uses JSON RPC 2.0.
JSON RPC 2.0, what is that exactly?
It's a well-established standard that allows different software programs to talk to each other and understand each other regardless of how they were built, like a universal translator for software.
Oh, that makes sense. So common language spoken over different channels. Okay, now what kinds of messages are they actually sending back and forth?
Good question. There are four main message types: requests, results, errors, and notifications.
Okay, break those down for me.
Requests are messages that expect a reply, like asking a question.
Got it.
Results are the successful replies to those requests. The answer to your question.
Makes sense.
If something goes wrong, the server sends an error message. These include standard JSON RPC error codes, but also allow developers to define their own more specific ones.
So it's like a way to troubleshoot problems.
Exactly. And lastly, there are notifications, which are one-way messages that don't require a response. It's like an announcement.
Okay, so we've got questions, answers, problem reports, and announcements. That covers the communication basics. But how does a connection actually get started and then ended? What's this connection lifecycle all about?
So the connection lifecycle has three phases: initialization, message exchange, and termination.
Okay.
Initialization is like a handshake.
Okay.
The client sends an initialized request to the server indicating its protocol version and capabilities. The server responds with its own information. Then the client sends an initialized notification to confirm.
So it's like a quick introduction to make sure they can understand each other.
Precisely. Once that's done, we move into the message exchange phase. That's where the actual work happens using those requests, responses, and notifications we talked about.
Got it. And then how does it all end?
That's the termination phase. Either side can end the connection cleanly using a close command, or it can end if the connection is lost or an error occurs.
Okay, that's a pretty clear picture of how this communication works. Now, the documentation mentions resources. What exactly are those in the context of MCP?
Resources are any kind of data that an MCP server wants to make available to clients. This could be the contents of a file, records from a database, the response from an API, even real-time system information. Anything, really.
So it's like the server is offering up a menu of information that the client can choose from.
Exactly. But it's important to understand that the AI client doesn't just have free access to all this data.
Okay.
These resources are application controlled. The client has to specifically request them.
So if an AI needs a specific document, it has to ask the server for it.
Precisely. Each resource is identified by a unique URI, kind of like a web address, you know?
Right.
It tells you the type of resource and its location. For example, it could be something like file.homeuserdocumentsreport.txt.
Okay, that makes sense.
Resources can contain either text data, which is good for things like code or configuration files,
Right.
or they can contain binary data, which is better for things like images or PDFs.
So how does a client even know what resources a server has available?
That's where resource discovery comes in. There are two main ways a client can figure out what resources a server offers: direct resources and resource templates.
Okay, tell me more.
Direct resources are pretty straightforward. The server provides a list of specific resources through a special endpoint. This list includes the URI, a name, a description, and an MIE type, which tells the client what kind of data it is.
Got it. So that's like a catalog of available information.
Exactly. Then there are resource templates. These are like fill-in-the-blank patterns that allow clients to construct resource URIs dynamically. It's more flexible.
So it's like saying, we have data organized this way, tell us the specific part you want.
Perfect analogy.
And how does a client actually get hold of the data once it knows the URI?
To get the content of a resource, the client sends a resources read request to the server with the URI. The server responds with the content of the resource either as text or as binary data.
Pretty straightforward.
And a single request can ask for multiple resources at once.
Efficient. What happens if the data in a resource changes? Does the client have to keep asking for the latest version?
Nope. MCP supports resource updates. The server can send notifications to clients when resources change. For example, if a new file is added or if the content of an existing file is updated.
So clients can stay up to date without constantly polling the server. That's smart.
Yeah, it's a really elegant system. Now let's shift gears and talk about tools. The documentation calls them model-controlled primitives. What does that mean, and how are they different from resources?
Yeah, I was wondering about that. Resources are all about accessing data. What are tools for?
Tools are about letting LLMs take action. It's about giving them the ability to do something with the data.
Oh.
The YouTube tutorial actually shows a really cool example of building a tool to search documentation. It's a perfect illustration of how tools work.
Oh, yeah, I remember that. It was about an AI assistant that could look up documentation before suggesting code. Can you walk us through that?
Sure, so imagine an AI agent has a goal. To achieve that goal, it needs to take certain actions. Those actions are the tools.
Okay.
The AI selects a tool to execute, and the result of that action is then fed back into the AI's reasoning process.
So the tools are like giving the AI hands to work with.
Precisely. And MCP allows for multiple toolkits, all using the same standardized protocol. So your AI could have tools for searching the web, interacting with databases, sending emails, you name it.
It's like giving the AI a whole toolbox to work with.
Exactly. Can you imagine how this could change things?
Yeah, yeah. Writing code, doing research, it could revolutionize so many tasks. The tutorial specifically showed a server that could help an AI check documentation for libraries like LangChain, Llama Index, and OpenAI. How did that work?
Right. So that server had a tool that would search the web for the latest documentation of a specific library, and then it would fetch the content of those web pages. So the AI can make sure it was using the most up-to-date information before suggesting any code.
That's really clever. It prevents the AI from giving out outdated or incorrect advice.
Exactly. And it's all thanks to that tool.
So how do you actually create one of these tools? The tutorial mentions something about a special marker in the code.
Yeah, it's called a decorator. In Python, you would write it as @mcp.tool.
Add mcp.tool.
You put that before a function definition to mark it as an MCP tool.
Okay.
That tells the framework that this function can be called by an AI agent. And a really crucial part of this is writing good documentation.
Documentation.
Yeah, those doc strings you always hear programmers talk about, they explain what the code does.
Right.
With MCP, these doc strings are really important because they tell the LLM how to use the tool, what parameters it needs, what kind of output it produces. It's like an instruction manual for the AI.
Makes sense. So the documentation isn't just for humans anymore. It's for the AI as well. The tutorial also mentioned debugging. How do you test these MCP servers to make sure they're working properly?
Debugging. It's a crucial part of software development. And the tutorial highlighted this great tool called the MCP Inspector.
The MCP inspector.
Yeah, it's a separate application that lets you connect to a running MCP server and interact with it directly. You can see all the available tools, read their descriptions, and even send test requests to see how the server responds.
So it's like a way to peek under the hood and make sure everything is running smoothly.
Exactly. It's a really valuable tool for developers.
Okay, we've covered a lot about what MCP is right now, but what about the future? The documentation had a roadmap for the first half of 2025. What's on the horizon for MCP?
The roadmap is pretty exciting. A major focus is on remote MCP support.
Remote MCP support, okay.
This is about enabling secure connections to MCP servers over the internet. And they're looking at things like authentication and authorization, making sure only authorized clients can access these servers.
That makes sense, especially if we're talking about sensitive data.
Exactly. They're also exploring service discovery. That's about making it easy for clients to find and connect to these remote servers. And stateless operations, which is a more technical detail about how servers can run efficiently in the cloud.
Okay, so it's about making MCP more accessible and secure over the internet. What else?
Another big area is distribution and discovery. They're working on a package management system, so it's easier to share and install MCP servers, like an app store, but for AI integrations.
That's a great analogy.
Right. They're also developing installation tools to simplify setting up these servers and sandboxing techniques to isolate them from each other for security. And they're even considering a server registry, which would be like a central directory where you can find and learn about different MCP servers.
So it's all about making it easier to find, use, and manage these MCP servers.
Precisely. And of course, they're also working on improving the AI agent capabilities themselves. They're looking at better support for hierarchical agent
The
systems.
hierarchical agent systems.
Yeah, that's about building more complex AI workflows where multiple agents can work together. They're also working on interactive workflows, which is about how these agents can communicate with users and streaming results, so you can see results in real time during long-running operations.
So the AI agents themselves are getting more sophisticated and responsive. That's
Mhm.
exciting.
It is. And last but not least, they're focusing on building a broader ecosystem around
A
MCP.
broader ecosystem.
This means encouraging community-led standards development so different AI providers can collaborate and shape MCP together.
That's important for long-term success.
Absolutely. And they're looking at expanding beyond just text to support additional modalities like audio and video, and maybe even formal standardization through an official body.
Wow. So it's not just about the technology itself. It's about building a community and a future for MCP.
That's the idea.
So to wrap it up, it seems like MCP is really trying to be that USB-C for AI, making it much simpler for large language models to connect with all the data and tools out there.
Yeah, it's about making it easier for developers to build truly intelligent applications.
And with all the developments happening with remote access, server management, and agent capabilities, the future of MCP looks pretty bright.
Mm.
Imagine a world where any AI application can seamlessly tap into a universe of specialized tools and data sources. What kind of incredible applications could we build with that kind of power?
It's mind-blowing, really. And if any of our listeners want to learn more and maybe even get involved, I highly recommend checking out the official Model Context Protocol website and their GitHub repository. You'll find all the details there. This deep dive has just scratched the surface.
It really has. Thanks for joining us on the deep dive, and we'll see you next time.
See you then.